In this problem, we have two spheres, a 0.5 kilogram sphere moving at 1.4 meters per second and a 0.75 kilogram sphere at rest. The problem is to determine the velocity of both spheres after they collide, assuming a perfectly elastic collision. So we start with the conservation of momentum, which is going to say that the momentum of sphere 1 before the collision plus the momentum of sphere 2 before the collision is going to be equal to the momentum of sphere 1 after the collision plus the momentum of sphere 2 after the collision. So we substitute in the values that we know, 0.5 kilograms for the mass, 1.4 meter per second. This one, of course, is at rest, so it has no momentum before the collision. And then after the collision, we have the same masses, but velocities v1 prime and v2 prime are unknown. These are the ones we're trying to find. Now, since it's a perfectly elastic collision, we can use this second formula that we derived in class that only applies to perfectly elastic collisions. And the difference in the velocities of v1 and v2 is 1.4 minus 0, so that's just 1.4, and that's equal to v2 prime minus v1 prime after we distribute through that negative sign. Now I'm going to solve for v2 prime, and that's simply 1.4 meters per second plus v1 prime. Okay, now I want to solve the equation. So what I'm going to do is to substitute in for v2 prime. v2 prime from the previous slide was 1.4 meters per second plus v1 prime. So I've substituted that in. And then I simplify by multiplying through the 0.75 kilograms to give me this expression. And now I need to just solve for v1 prime. So I'm going to combine like terms here and here. That gives me 1.25 kilograms times v1 prime. And then I'm going to subtract 1.05 kilogram meters per second from both sides. And that's going to give me negative 0.35 kilogram meters per second. And the last step is to divide through by 1.25 kilograms. So that tells me now that v1 is negative 0.28 meters per second. So that actually means, by the way, that sphere 1 bounced back this direction because the sign of the velocity is negative. Okay, v2 prime, meanwhile, is 1.4 meters per second plus v1 prime. So substituting this in here, v2 prime ends up to be 1.12 meters per second, and we've solved the problem.